A great deal of ink has been spilled on the subject of horizontal tracking error and the relative merits of using one alignment scheme, Lofgren, Beyer-Wald, Stevenson, versus another. And of the last couple of decades, even more has been written about the merits of longer tone arms versus shorter tone arms in order to reduce horizontal tracking error. Of course, the reason for being of linear trackers is to reduce it altogether. But missing from this conversation and from the huge efforts put into design, assemble, and set up arms that take advantage of the improved horizontal tracking error is perspective. Perspective is really missing here. So let's put horizontal tracking error in perspective to something else that has been ignored. On a pivoted tone arm, as a cartridge sweeps across the record, it hits, of course, two null points where there is no angular error, horizontal angular error. But outside of those two null points, there's always error. And in a typical pivoted arm, at that inner area of the record, you're looking at about 1.9 degrees of horizontal tracking error. The reduction in that same tracking error between, say, a 12-inch versus a 9-inch arm is only about 0.4 degrees. Not much. And again, all of this error is focused on the last few millimeters of playing area of the record. And by the last few millimeters, I mean literally about the last 3 millimeters. And I should say many records aren't even cut that far, as close to the center of the record, so you never actually get to it on many records. So consider that. At worst, we're looking at about 1.9 degrees of error at the last few millimeters of playing area on some records. Now, the mechanical and electrical distortion created by that horizontal tracking error is identical in all but one respect to vertical tracking error. The only difference between horizontal tracking error and vertical tracking error is that horizontal tracking error is obviously done on a horizontal modulation and vertical tracking error is on a vertical modulation. Now, vertical tracking error, that's our VTA. All right? So the error then on vertical tracking error is between the VTA of our cartridge and what it should be. I did a video on this, of course, part of the 7 alignment targets of analog optimization on VTA, where I lay out that the optimal VTA for us to aim at is 18 degrees. This is because the bulk of most records cut over the years have been done on Neumann cutter heads, and most of the other cutter heads are actually cut at less than 18 degrees. Particularly when you take into account something called lacquer springback. However, and here's the kicker, vertical tracking error, the average vertical tracking error, that is the difference between what the average cartridge is at for its VTA on a level head shell, under nominal tracking force, under stylus friction, versus where it should be, let's say 18 degrees, is 9 degrees. The average cartridge is 9 degrees away from where it would optimally be on the vertical plane over the entire record surface, not just the last few millimeters where we've got 1.9 degrees of error in the case of horizontal tracking error. So consider that discrepancy. VTA is a much bigger problem than horizontal tracking error. So why are we arguing about the difference between Lofgren or Beyer-Wald or Stevenson, or 9-inch arms versus 12-inch arms, or even linear trackers versus pivoted, when we've got this huge difference in the market? Now, how do I know that the average tracking error is 9 degrees away from where it needs to be? Because we've analyzed several hundred cartridges in our lab as part of our cartridge analysis service. We document every cartridge that comes through here, and we know where they are. So you can see the argument over 9-inch versus 12-inch, or linear versus pivoted, it's focused in the wrong area. If we get the cartridge manufacturers to lower their VTA, we would experience much bigger gains than we would if we go from, say, a pivoted arm to a linear tracker. Why are cartridge manufacturers so far off from optimal? Well, I discuss that in my video on VTA. I encourage you to watch it. We'll release more information about this in the future, but suffice it for now to say that the primary reason why cartridge manufacturers are too high with their VTA is because cartridge manufacturers, tend to unjustifiably get the blame for sibilance and mistracking when sibilance and mistracking is almost always a tone arm related issue. This, of course, is a Wally skater measured function and why the Wally skater is our most important tool. Until next week on the next soundbite, see ya.